Hello, this is just a quick and dirty intro to acids and bases. We'll go over some properties and some strong acid, weak acid, strong base, weak base types of formulas, and we'll go over pH scale very quickly. So without further ado, we'll go ahead and start in some properties of acids. First of all, if you think of acid, you're probably thinking of something like orange juice, lemon juice in the refrigerator. Most of those taste sour. So most of the acids that you can taste have a sour taste to them. They react with bases to form salt and water. Now there's hundreds of types of salts, so remember it's not all NaCl. So the acids react with bases to form salt and water. Acids turn litmus paper red. These notes I'm writing down are all the answers for your CFU worksheet for acids and bases. They also looking at properties of bases. Bases feel, if you got your fingers and you rub them together after putting them in a dilute base, they would feel very slippery. Pardon me if I spelled that wrong. They also react with acids to form, same thing as the top, salt and water. That's a very famous question, so you may want to remember that for college. So acids and bases react together to form salt and water. Last question I would ask is litmus paper. Bases start with the letter B, so guess what color they turn litmus paper? Blue. See the B's? Okay, let's look at these 6 strong acids and let's explain the difference between a strong acid and a weak acid. Strong acids are, I always remind people, it's like my wife. If I cheat on her, she's going to break up with me 100% of the time. That's a given. 100%. She's leaving me, never, ever, ever, ever coming back. We all know weak acids, though, don't we? Those are people that break up and then they get back together. They break up, they get back together. So think of relationships, I guess, to help you understand weak acids and strong acids. Now there's hundreds of types of weak acids, but there's only 6 strong acids. So most people just memorize those. They are sulfuric acid, perchloric acid, hydrochloric acid, nitric acid, hydrobromic, and hydroiodic. Those are the 6 strong acids. Much like the 6 strong acids, strong bases also completely disassociate that are strong. So we start with sodium on the periodic table, and if you look at a periodic table, it makes a letter B. So you come down sodium, potassium, cesium, rubidium, and then you come back up to calcium, strontium, and barium. It makes the small letter B on the periodic table. Notice that all strong bases contain OH. So the calcium, strontium, and barium contain 2 OHs. Now, flipping ahead to the pH scale. You may have seen this before, but you definitely need to look at it one more time. So you've probably never heard of the pOH scale. Well, before we begin with that, let's check out the pH scale. Some people say it's percent hydronium. Hydronium is nothing more than H plus in water, so H3O plus is what some people want to call it. That's the proper name, but because I'm lazy, I usually just go H plus and assume that it's in water. So without further ado, let's look at the pH scale, 0 to 14. 7 is what we would call neutral. So that's neither an acid nor a base. From 0 to 7 on the pH scale, though, would be acidic. And 7 to 14 would be considered basic or alkaline. Okay, those are things you probably learned in middle school science. But look on the bottom, the pOH scale. It's just looking at it from the opposite direction. This is normally when I would run to the back of the room and stare at everyone from the back of the room and say, have y'all changed? No, just my perspective of you has changed. So if you're looking at a substance, let's look at these 3 problems. The pH is 3. You go to 3, what comes down below it? 11. Now that's the quick and dirty way of figuring it out. Someone also could go 14 minus 3 equals 11 as well. That's the formula way to calculate that. But I've seen college level kids draw this out, and then that way it's really, really quick and dirty. So if the pOH is 8, you put your finger on 8, and you come up, and the pH is 6. See how easy that is? Now, one thing that your middle school teacher probably didn't tell you is what is the pH scale really? 3 is not really a 3. 2 is not really a 2. Then what is it, Coach Key? Well, let's start with 1. 1 is really 0.1 molar H+. So what would 2 be? And this is where everybody says 0.2. No, it's 2 steps from the decimal place. So it's a logarithmic scale. 0.01 molar would be 2. So what would 3 be? 0.001, or 1 times 10 to the minus third. Oh, so 1 times 10 to the minus third, H plus has a pH of 3. If you don't like that, you can always type in negative log of 1 times 10 to the minus third to get 3. That's how we got the pH scale. Now let's look at these last 2 questions, and we'll finish with those. So if H plus has a concentration of 1 times 10 to the minus 4th molar, remember molarity from the last lesson, then the pH is simply 4. Yes, it's that easy. Notice there's no unit on pH. It really bothers me. I hope it bothers you a little bit, but there's no technical unit for pH. What about the last one? If the OH minus concentration, wait a minute, I haven't covered that. But I bet you're smart enough to realize it's the same but on the bottom. So if the OH minus concentration is 1 times 10 to the minus 13th, you just take the pOH over to 13, and that's your answer. I hope this helped a little bit with your CFU worksheet. We'll be doing another one on calculating concentrations right after this.